In the previous session, we had covered simple basic file I/O in LabVIEW. Today, we are going to cover certain specific formats which are used for file I/O in LabVIEW, that is TDMS. We are also going to talk about certain other file formats. My name is Avichal and I am an applications engineer with National Instruments. If we talk about the various file formats available in LabVIEW, the list is very large. Right from the basic file formats, for example binary and text-based formats, for example ASCII files, we can have complex file formats also. There are various NI standard formats which are extensively used for measurement files. For example, TDMS, LVM, DAT, etc. If you can see, there's a link shared on my screen, which is a white paper on our website 4065. You can refer to this white paper to understand what all file formats are compatible with LabVIEW. You can directly read various file formats in LabVIEW using the APIs, whereas for certain other formats for which the APIs are not available, you can use data plugins and can call these files in LabVIEW. So let us talk about measurement data. If we want to log measurement data, it's not like any simple text-based data. Apart from the data that is to be logged, there is a high amount of information which is also to be noted when we are measuring from various instruments. For example, if I have a thermocouple data logging system, I might need to know what kind of thermocouple I am using, what is the unit that I am measuring the temperature in, and other types of properties for this particular measurement. So from NI, we have two standard formats for this particular purpose, which are the LVM format and the TDMS format, the LabVIEW measurement file, that is LVM, or the technical data management streaming file, which is the TDMS. You can use express VIs, for example, write measurement file and read measurement file to access both of these formats. Whereas, especially for TDMS file format, there is a palette which is available in LabVIEW, which we are going to discuss in detail today. Now we have various file formats which can be used. Then why is it that we have a need for TDMS? The reason is various files or the various file formats have their own advantages and disadvantages. So National Instruments, they have developed the TDMS file format to help scientists properly store large amounts of data that they generate during simulation and results. With an easy to use interface for storing well organized and documented files, they can focus on your efforts on more pressing areas of their applications rather than getting concerned about the data storage itself. That is the process. So if you can see on my screen, I have shared that in comparison to various database files or various data logging file formats that we use, TDMS has most of the options which are available. And hence we use such a file format. The TDMS file will actually contain two kinds of data. First one will be the metadata, which will be containing the information about the channels, about their properties, about various groups. And secondly, there will be the raw data, which will be the actual data which is being used. The TDMS files can be used for various purposes. For example, storing test or measurement data, to create an organized structure so as to group your data according to various parameters, according to various sensors, according to various groups. You can also store information, headers, properties, etc. about your data. And most importantly, the TDMS file write and read are occur at a very high speed. As I said, you can use TDMS file to structure or organize your data. This is how the TDMS file structure looks like. I have a data, I have a file, and that file has particular properties. For example, it may be the description of the file, the title of the file, the author of the file. Under the file, I'll be having various channel groups. These channel groups may be grouping of various sensors. For example, a particular channel may be defined for storing temperature data. And under that channel group, I'll be having various other channels that will be acquiring information from various temperature sensors. And these groups and these channels have their own. So how do we go about and use the TDMS file format? In LabVIEW, we have a TDMS streaming palette available, which also hosts the advanced TDMS palette, along with two express VIs, the read from measurement file and the write from measurement file VIs, which can be used for this particular purpose. The common programming architecture remains mostly same as you saw for basic file I/O. I'll be creating a file, that is, I'll be creating a reference to a TDMS file. Then I'll be performing a streaming to a file, that is reading or writing. And finally, I'll be closing the file. But apart from these basic things, I can also do several other stuff. For example, if you see this second VI, it can be used to modify the properties of a particular channel. And if you see this VI, this can be used to see the file size of the TDMS file. The last VI that you see here is a TDMS file viewer VI. Using this, you can actually view your TDMS file data in a very organized manner. So I'll do one thing, I'll go ahead and show you a demonstration on this so that these things become much more clearer. So I go ahead and open a new VI. So there's the front panel and the block diagram. I open the functions palette. I'll go to file I/O. In that, I'll go to the TDMS file palette. First of all, I'm going to open a particular TDMS file. And then let's say I want to write some data to this TDMS file. Once I'm done with writing of the data, I'll be closing this file. So just like a common architecture, each of these VI needs a reference to the file which I have created. So I create a control for giving the file path. Then I define a group name in my right VI. Now I have to have some data to be written to this file. Now unlike binary and other files where I have to give in a text or a string format, for TDMS files I can directly wire in waveforms so that the waveform data along with its properties is stored directly to the file. So I'll just go ahead and simulate a signal so that I can write on this signal's data to the TDMS file. Let's say there is a 1 kilohertz signal with, let's say, an amplitude of 10 and an offset of 2 with some random noise. So this has been configured for 10,000 samples. So I'll be getting in these 10,000 samples to the TDMS file. So I've given already the group name. In the group I also have a channel, so I create a control for that also. So I can define my group name here. I can define one of my channels here. Now since I am creating a new file, I'll have to change the operation to open or create, so that if there is an existing file, it will just open that up. If there is not an existing file, it will create a new file. Let's say I create this file on the desktop. I'll just go ahead and write the path here. Let's try to run this VI. So this creates a file over here, which is a data.tdms file. Now there are various options of reading this file, but the most simple one and the most basic one is the TDMS file viewer VI. So I'll just go ahead, delete the content of this VI and drop this single VI. So that I just mentioned the file path, this one, and I run it. So this TDMS file viewer actually opens up a window where I can see my TDMS file, all of its groups and all of its channels. So I just added one group, which was group 1. In that I added one channel, that was channel 1. Now to see the properties of this channel, I click on this and I get various kinds of properties of this channel. What was the length, what was the name, what was the starting timestamp, the waveform data. All of these properties are listed over here. If I want to get the raw data, that is the values, those are listed over here. If I want to see the analog values, that is the graph, that is again visible here. Once I quit this, the VI will be stopped. Apart from this, there are various other functions that you can implement which I would like to show to you. So it might be needed that you want to gain some information that what all groups and channels are available in this file. So you can use this particular VI, that is the TDMS list contents VI. And also if you want to change certain properties, that is for example the channel name, the waveform information, etc., you can use the other VI, which is the TDMS set properties VI, this one. So I'll define my group name, my channel name, along with the property names and their values, so as to change the properties of a particular channel. Now sometimes it might be required that I want to create some kind of an edition on my file at a particular location or at a particular offset. So for that I use the advanced TDMS streaming palette, where I have advanced opening and closing functions along with setting the next read or the next write position, so that I can configure exactly where I want to start the read or start the write function. One more very good thing about TDMS files is the versatility of it. You can use TDMS files in various softwares. First of all, NI software. You can access TDMS files in LabVIEW, CVI, Lab Windows, DRM, LabVIEW Signal Express, Measurement Studio using .NET languages, etc. You can use TDMS files also in certain other softwares which have the capability of DLL communication. So NI distributes a TDMC DLL, and this DLL can be used in various other softwares, and thus the TDMS files can be read from those softwares. Some examples are OpenOffice.org Cal and MATLAB, etc. TDMS files actually store spreadsheet kind of data. Therefore, they can be used with Excel and other softwares which can read spreadsheet type of data. Now apart from TDMS, there might be various other formats that you would like to use in LabVIEW. So for using various kinds of format, you can either go ahead and use the basic file IO functions, which are capable of reading any binary file or any file that is stored in form of bits on your computer, or rather you can use file format specific VIs which are available in LabVIEW. For example, Excel files and Word doc files are two very commonly used file formats for applications. Therefore, we have Word specific and Excel specific palettes available in LabVIEW, which can be directly used to access these kinds of files, edit them in LabVIEW itself, place charts with different kinds of tables, etc. on these files, and thus use them. Actually, these palettes are part of the report generation toolkit palette, which is actually a very vast topic, and certainly we'll be doing a webcast on these things also. So once we are doing a webcast on report generation toolkit, you will get an excessive information on how to use these VIs for including other type of file formats also. So this is it with the today's webcast session. The contest of this week is now live on the LabVIEW Enable community, that is labviewenable.in. I'd like to announce the winner of last week's Wednesday webcast. The user profile is Shweta_Valanch. So congratulations, you will be receiving a personal message in your community profile with further details. You can extend your Webcast Wednesday learning experience on LabVIEW Enabled, the NI India online community. The NI India community is a single network of students, industry professionals, and academicians collaborating and coming together to create discussions, exchange and share resources, generate content on applications, NI technologies, as well as the industry trends and other third-party technologies. It serves to unite users not only from India, but also across the world on collaborating on similar applications. Simply put, it's a social network for engineers, students, and researchers. Apart from the live online interaction during the webcast, an extended discussion and a construct on the topic is being carried out that will be available for the complete week. You can also watch the previous episodes of Webcast Wednesday. You can participate in weekly contests to win up to 50% discounts on National Instrument Certification exams. You can attend 20 sessions to win a free CLAD attempt. To watch the recording of this session and to participate in the contest of the week, the resource is www.labviewenenabled.in. As you land on this page, just click on the Webcast Wednesday graphic that you see. You will be able to participate in the contest of the week as well as watch the recording of this session. Please note the recording will be uploaded on the community page in 3 hours from